Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and we will continue with our series of Quant CAT 2025. The topic that we have been covering for the past almost 1 month is geometry, and today it's the day for circles. So, let's look at what kind of questions or what are the question types we get in CAT. Some of them may look very easy, some of them are going to be of moderate level of difficulty, and we will solve them as we go ahead. We will discuss the concepts if there are any. So the first question says, let ABC be a right angled isosceles triangle with hypotenuse BC. So right angled isosceles triangle. So this is A, this is B, this is C, and this is 90 degree, and they are equal. So this is an isosceles right angle triangle. Let BQC be a semicircle away from A. So we are told to draw a semicircle away from A. Okay, and this point is given as, let's say, Q here, with diameter as BC. BPC be an arc of a circle centered at A and lying between BC and BQC. BPC is an arc of a circle centered at A and lying between BC and BQC, and it is BPC. So basically, it is telling us that if we draw a circle, so we are going to get a circle of this type by taking A as the center. Okay, the thing is, the hypotenuse is BC, so that's why I was confused. Okay, let's redraw. So we have a right angle isosceles triangle, which is ABC, where BC as the hypotenuse. And then BQC is the semicircle with diameter as BC. So this is what we are going to have. So the center is going to be here. And this point is, let's say, Q. Now, if we take A as the center and if we draw a circle, so this is the circle we are going to get, or quarter of a circle basically. And this point is given as P. So BPC is the quarter of a circle with center at A. If AB length is 6 centimeter, then the area of the region enclosed by BPC and BQC. So we are asked to find out what would be this particular region's area. So if this is 6, this is going to be 6 centimeter, and the hypotenuse is going to be root 2 times of 6. If that is going to be root 2 times of 6, that is the diameter. So this part is going to be, as in the radius is going to be half of that. Half of 6 root 2 would be 3 root 2 centimeter. So in order to get to the answer, what we can do is we can calculate the area of this semicircle. So area of that semicircle is going to be half the area of the entire circle with radius as 3 root 2. So this is half times pi into 3 root 2 whole square, which if we solve is going to give us 9 pi centimeter square. Now from this, what we see is this is the area which is the quarter of a circle with radius as 6. So area of that quarter of a circle is going to be 1 by 4 times of pi, And here the radius is going to be 6, so it's going to be 6 square. So 36 by 4, which is going to give us 9 pi centimeter square. So what we realize over here is the area that we have above and the area that we have below, the one that is shaded in pink and the one that is shaded in blue, they have the same area. They may not look same, but they are same, right? Now, if we want to calculate the area of this region, right, we can say that the area of this region is going to be area of the quarter of the circle minus area of the triangle, right? So what will be the area of that shaded region? This is going to be 9 pi centimeter square minus area of the right angle triangle, which is half into 6 into 6, which is going to be 9 pi 36 by 2, which is going to be 18, right? So 9 pi minus 18 centimeter square. Now, the leftover. So if we want to calculate the area of this region, which is enclosed between BPC and BQC, we can say that its area is area of the semicircle minus the area of the shaded region. So if we subtract, 9 pi gets cancelled out and we will be left with 18 centimeters square. Basically, the area of that region is going to be the area of the triangle that we see. Right? Very much unexpected, but that's what it is. Right? Okay. In a circle, two parallel chords are on the same side of the diameter and have lengths 4 and 6 centimeter. So we are going to have a circle, and in this circle, we need to have a chord whose length is 4 and a parallel one whose length is 6. And they need to be on the same side. So if I take this to be the center, either it draw करना है. So parallel, and this is 6. And we are told that the distance between them is 1. We need to find the radius of the circle. So if we join this, this is the radius of the circle. If we join this, this is also the radius of the circle, right? And if you drop the perpendiculars from the center, it will bisect, isn't it? So the entire thing was 4, so this is going to be 2. Entire thing was 6, so this is going to be 3. And this is 1. So let's erase this part. Okay. This distance is something that we need. Do we need this distance, or can we simply break it down? Let's call this as X. Now, if I name the points as O, A, B as the chord, C, D as the other chord, this point as P, this point as Q, then in triangle AQO, which is a right angle triangle, using Pythagoras theorem, we can say that R square is equal to 3 square plus X square. And in triangle CPO, which is also a right angle triangle, right? We can say that R square is equal to 2 square plus 1 plus X whole square. We are asked to find out the radius, which means we need to get rid of the X somewhat. So what we can do here is, from the first one, we can write X is equal to R square minus 3 square under root. And from the second one, we can write X plus 1 is equal to under root of R square minus 2 square, or basically X is going to be R square minus 2 square minus 1. Now we can equate these two and solve it. The thing is, it's going to be very much time consuming because we will have to square it twice. So how about we will use the options? So let's put in the first value, which is going to be under root 11. So if I put under root 11, that is, these are the values of R, remember, right? So if R is under root 11, R square will be 11. So 11 minus 9 under root, which is going to be under root 2. And this is 11 minus 4 under root, which is going to be under root 7. They are not same. So first option is gone. If we take root 14, so we will have root 14 minus 9, which is root 5, which is not same as, obviously, because irrational values will not be same as irrational plus minus integral value, right? So be bigger. If we choose C option, this is going to be under root 13 minus 9, which is going to be under root 4, which is 2. And root 13 square, which is 13 minus 4, which is going to be 9 ka square root, 3 minus 1. So they are equal. So root 13 becomes answer. So when you get stuck with irrational ka equation, try not solving it if you have options. Worst case, if this was not an option, which could not be because it's irrational in nature. So we will have to use options for faster solution. Right. Next, let ABCD be a rectangle inscribed in a circle of radius 13 centimeter. So we have a circle with radius 13 and there is going to be a rectangle. Now the rectangle has to be like the one where the center is going to be the meeting point of the diagonals of the rectangle. That's how rectangles are drawn inside a circle. Okay, so ABCD is the rectangle where AC or BD, that's 30. Which one of the following pairs can represent the possible length and breadth of ABCD? So I'm going to erase one of the diagonals. And if this is going to be 13, right? Sorry, radius is 13, so diameter is going to be 26. If this is 26, then what kind of triplet will it work with? Well, the triplet we have is that of 5, 12, 13. If I double everything, we will have 10, 24, and 26. So 10, 24 is what we should have. Or we can use the options and find out which, from the option, which number square plus the other number square is equal to 26 square. That will also give us the answer. Right? So pretty easy, but this question has come in CAT before. Another one. On a triangle ABC, a circle with diameter BC is drawn, intersecting AB and AC at points P and Q respectively. Okay, so we have a triangle ABC. Okay. Where AB is 30, AC is 25. No idea about BC, so this is A, B, C. With diameter BC is drawn. So if we draw a semicircle, circle draw करना है. So looks like it may not touch it. AC looks like perpendicular to BC. It's 90 degree. That's why it doesn't look like that it will touch. So let's draw an isosceles triangle. Better. So this is going to be BC. This is A. Now this has to touch. Cross kare. AB pe at P, AC pe at Q, and center is, let's say, at O. And the lengths that are told to us are AB is 30, AC is 25. We are told CP is 20. This is going to be 90 degree, right? Because BC is the diameter and there is a triangle drawn BPC. So what 20 over? Excuse me. We need to find the length of BQ. If we need to find the length of BQ, for that we will need to find the length of QC as well as BC. For that, fine. So let's visualize this triangle like this. Let's not draw the circle. So we have this triangle ABC, right? Where this length is known to be 25. Also, there is a perpendicular drawn from C on AB, CP, where the length of the perpendicular is given as 20. And this entire length of AB is also given to us. So what we can do is, in this particular triangle, which is a right angle triangle, we can find out the triplet. So 20 and 25 will form the triplet. This is 4 into 5. This is 5 into 5. 5 is common, right? So this should be 3 into 5. So this is going to be 15. If this is going to be 15, this is also going to be 15. So we get to know that this is nothing but the midpoint. Now, in a triangle, if we happen to draw a perpendicular, and if it bisects the opposite side, then this is definitely an isosceles triangle, right? Okay. So, an isosceles triangle. If I complete this circle with center as O, the next part is, if we have a circle with center O and then there are two chords that meet outside, the chords being AB and AC, sorry, PB and QC, they meet outside at A. And if we know that AP is 15, BQ is 15, AQ is not known, and AC is going to be 25. So circle. This is 30. So AP into AB should be equal to AQ into AC, right? Now AP is 15, AB is 30, AQ is X, and AC is going to be 25. So from here, we will get the value of X as 18, I believe. 5, 3, 6, 18, right? So what we get here is AQ is 18. So that would mean this is going to be 7. This is 7. This is 25. ऐसे कैसे? Remember? Isosceles triangle. So this is 7, this is 25. If we join BQ, this is also going to be 90 degree. We can use Pythagoras theorem to solve this value, which is going to be 25 square minus 7 square under root, right? That's what BQ will be. So this is going to be 25 minus 7, 18, 25 plus 7, 32 under root, which is going to give us 3 into 64 square root 8. So 24. So 24 will be the answer. Well, instead of this, we could have used similarity, but then would that be Q1? हो सकता था. Okay, similarity कैसे? So let me explain. These two sides, they are in the ratio of 6:5. So the corresponding lengths, they also needs to be in the ratio 6:5. So 20 की जगह 5 दिख रहा है और 5 की जगह 20 दिख रहा है. तो 6 की जगह we should see 24. Okay, but then this would be a very far-fetched solution because normally in the case of circles and triangles we do not see similarity that often. मतलब हमारा outlook वैसा नहीं होता है, right? Okay. The next problem. A chord of length 5 centimeter subtends an angle of 60 degrees at the center. So this is 5 and center page subtends an angle of 60 degrees. The length of the chord that subtends an angle of 120 degree at the center of the same circle. So this is 60 degrees. They both are equal. So basically we are talking about an isosceles triangle where these two should also be equal. So it turns out to be 60. So basically it turns out to be an equilateral. So ये भी 5 और ये भी 5 होगा. Now if we need to find out a chord length which subtends an angle of 120 degrees at the center, where of course the radius is 5, we have just calculated this. Then this length is going to be 5 and 5. So this is going to be 60 degrees. This is going to be 30 degrees. 90 ke opposite, if we have a 5, then 60 ke opposite, we will have 5 by 2 root 3. Same thing will happen on the other side because it's an isosceles triangle. So the total length of the chord, which subtends an angle of 120 degrees at the center, will be 5 plus root 3. It will obviously not be in terms of pi. AP is the diameter of a circle of radius 5 centimeter. So AB is basically the length, which is 10. So radius is 5. P and Q be 2 points on the circle such that length of PB is 6. Okay. So we need to have a P such that its length is going to be 6. And the length of AP is twice that of AQ. So basically this length is 2 times of this. So if we call this length as L, this is going to be 2L. Find the length of QB and nearest to. So what we see here is APQ is nothing but a right angle triangle. It's the triangle subtended by the diameter of the circle onto one of its points on the circumference. तो Pythagoras लगाते हैं. So the length of 2L will turn out to be 10 square minus 6 square, which is going to be 100 minus 36, which is 64 ka square root, which is 8. So L turns out to be 4. So this is going to be 4. Again, if we look at AQB, this is also a right angle triangle. So the side is going to be 10 square minus 4 square, which is 100 minus 16, which is under root 84. Now, under root 84 is going to be 9 point something. Now, is it going to be 9.1 or is it going to be 9.3? That is something that we need to figure out. Now 91 square is 8100 plus 91 plus 92, which is 180, 90 plus 91, which is 181. So this is 8281. So basically saying 82.81 ka square root would be 9.1. And if you take 93 square, this is going to be 8100 plus 3 times of 90 plus 93, which is 183. Pretty far. Ninety and 93 should be added, and it should be added 3 times. This turns out to be 8649. So 86.49. Looks like. So both दूर है options. So 8400, is it closer to 88, 8281, or is it closer to 8649? 8281 is approximately 119, exactly 119 away, while this is 249 away. This is way, way far. So the closest one is going to be 9.1. Actually, the 9.2-ish hona chahiye. But he don't have an option which is 9.2. Okay. Let C be a circle of radius 5 meters, having center at O. So this is center O. Let PQ be a chord of C that passes through points A and B, where A is located 4 meters north of O. 4 meters north of O, and B is located 3 meters east of O. So this is 3 meters east. This is 3, this is 4, and this point is O. So इसको join कर लेते हैं, इसको join कर लेते हैं. And we need to have a chord PQ जो इससे pass करता है. O, A, and B. Then the length of PQ in meters is nearest to. Okay. The thing is, if this is 4, this is 3, and this is right angle triangle, so this is going to be 5. Now, the entire length or the entire radius is 5. So this is going to be 1, and this is going to be 2. If we happen to join this, what will happen is these two angles are same, right? So there is no similarity as such. Are they going to be isosceles in nature? Maybe. Who knows? Good question. Do they look isosceles? No, they look not exactly isosceles. Do they look more than 2? As in, is BQ more than this particular length? Let's call this as C and D. So is BD and same as BQ? Is it? Because if it is same, we know where to go to. If BQ is more than BD, वो तो depend करता है कि how accurate the shape is. एक्यूरेट ही है, isn't it? नहीं, वो 2 और वो 3 तो नहीं है. It should be more slant. Still, it should be more than 2. नहीं? How will you prove it? Because without proving, it won't be easy. इसको तो देख के सॉल्व किया जा सकता है, but then the thing is 3 and 2. हाँ, अब ये 3 ये 2 दिख रहा है. It makes sense. Still doesn't change anything. It's still greater. Right? Excuse me. So if this is 2, this is going to be more than 2. If this is 1, this is similarly going to be more than 1. So the total length of PQ is going to be 5 plus something more than 2 plus something more than 1, which should be more than 8. And more than 8, we have only one option. You know? Shall we do something else? Because the other solution, I think, is going to be not easy at all. Equation आएंगे, there will be 2 variables if I solve it properly. So please do let me know in the chat if you want me to solve it, step by step by drawing everything. If not, we will. I mean, I'm fine with this. I'm all good with this approach. मुझे कोई problem नहीं. Okay, another one. Let C1 and C2 be 2 concentric circles such that diameter of C1 is 2 centimeter long than C2. So C2 is at the center and C1 is outside. So if this is the radius R, this is the radius which is going to be R plus 2. And then we are told that a chord of C1 that is outside ka, it's a tangent to this smaller one. And it has a length of 6. It has a length of 6 और ये यहाँ से pass करता है. So obviously this is going to be 3, this is going to be 3. Then we need to find the diameter of C1. So याद रखने के लिए C2 is the one which is inside and C1 is the one which is outside. Right? So what I'm going to do is I'm going to join this. So this is R and this is going to be R plus 2. 90 degree because it's a tangent. Tangent page has to be perpendicular. So R plus 2 whole square is equal to R square plus 3 square. So we will have 4 plus 4R is equal to 9, or we will get diameter, that is 2R, is equal to 9 minus 4, which is 5 by 2. Fine. So the diameter of C1 is going to be R plus 2 ka double, which is going to be 2R plus 4. 2R ki value we already know is 5 by 2 plus 4. This is 8 plus 5, 13 by 2. So this should be the radius of this. Fine. Normally in theta, we do not expect a decimal value, but you never know. Okay, another one. In a circle of radius 11 centimeter, CD is the diameter. So this is C, this is D. Radius is 11, so this is 11, this is 11. Let's call this as O. AB is a chord of length 20.5, and AB and CD intersect a point at E inside the circle, and CE has a length of 7. So 7 means it should be closer to this. So this is the point E, and this is, let's say, AB. So what we get is CE has a length 7. This is our E. Total was 22, out of which 7 is gone. So we are left with 15 here. If I take AE length to be X, this is going to be 20.5 minus X. Find the difference of the lengths of BE, which is 20.5 minus X, and AE, which is minus X. So basically, we need to find out what is 20.5 minus 2X. का mod ले लेते हैं, because I do not know right now as to where is A. A इधर है कि ऊपर है, right? So we don't know this. ठीक है. So using the same logic that we have seen before, when two chords meet each other, the product of the distances from the meeting point, here the meeting point being E, it has to be constant. Now, if I open this, this is going to be a very, very bad quadratic to solve. So what I will do is I'll start using options. I'll choose option A. Suppose if this is 3.5, so X turns out to be 8.5, and 20.5 minus X will turn out to be, so basically this is 8.5, and this is going to be 12. Is 8.5 in the table of 7? No, it's not. Since there is a 7, we need to see a 7. It can't be 3.5. Let's look 1.5. If this is 1, sorry. If this is 1.5, so 2x is going to be 19. So x is going to be 9.5. If x is going to be 9.5, we need to stop right here. Reason being 9.5 is a multiple of 19. I don't have a 19 here. Okay, 1.5 bhi nahi hoga. Let's take 2.5. If I take this as 2.5, this is going to be 18. So x is going to be 9. If x is 9, this is going to be 20.5 minus 9, which is 11.5. Oh, this is in the table of 7, right? But is it in the table of 7? No, it's not. तो अगर ये तीनों ही नहीं होंगे तो D ही होगा, obviously. So if I take this difference to be 0.5, we will get the value of x to be 10. If x is going to be 10, this is going to be 10 into 10.5, which becomes 105. This is also 105, right? So anyways, if the first three options did not make sense, the last one option. So whenever you come across something like this, do not open the brackets and start solving that as a quadratic. It's not a smart move. Wastage of time, basically. Okay, so in the chat, nobody has asked the proper solution for the previous problem. So I hope you understood that if some length looks longer than the other, we will assume it to be the. So Mr. Shashank is going to take a session on 20th of May, the next Tuesday at 8:30 p.m. on YouTube. He will continue with his arithmetic time and work part 2. This is session 7 of the series roadmap to QA success. Please make sure that you attend this session. And if you're looking for test series, nobody in the market is closest to what our test series provide. And it is curated by, IIM alumni. You will find that it's right now it's not that costly. It's only 999 as of now. Okay, but there is an asterisk, so please do understand the terms and condition before you enroll for it. Okay, and we have already started with our Blackie batch. Now this batch gives you a guaranteed selection, of course under certain conditions, as in you need to attend classes, because if you do not, how will I guarantee it that whatever I have taught you, you will be able to use it in the exam, right? So Mr. Gautam Baba, who is an alumni of IIM Calcutta, he is taking care of the batch. The timing of the batch is on Fridays at 9:30 p.m. If you guys have any queries regarding that, there is the inquiry number. There is an inquiry number at the bottom right corner as well. Feel free to give us a call. And in case if you have any doubts, feel free to comment. Thank you, everyone. Please subscribe to the channel, like the video, and share it with your friends. Until next session, take care.